So, you'll see with these questions, go through these last couple and then we can have a look at the word problems where you need to be able to set up your own questions. Because this type of question is, you know, if I gave you this and said it was a criterion A assessment, it's just testing your skills, but it makes it more challenging. It's in a situation you maybe not seen before, so you'd be looking at getting to 7s and 8s, okay? But it's not really like, I wouldn't give this as a criterion D question, like an application in real life. So I need to give you those words so that we're ready for those. So let's have a look. So what do you notice about the diagram first off? There's 2 triangles. Okay? There are 4 sides, but it's definitely 2 triangles. And quite sometimes, however, they don't necessarily split it for you quite nicely like that, but they have in this case. And we should read this and just check all the information that they've given us in the question is on the diagram. So we said AB is 16, so A to B being 16, that's there. A to D is 12, that's there. Angle B to C to D is 40, that's there. Angle ADB and CBD are 90, so they've given everything. So the one that we're being asked to find out is length CD. So if I call that my X value, okay, that's what I'm being asked to find. So, when you do questions like this, don't be afraid to draw all over the diagram and make sure you know exactly what you're doing. So, I've got this, that's the triangle that I'm looking at that I need to find. Now, do I have enough information on that triangle to solve anything on it? No. That's the first realisation. I don't have enough information there. What do I need, Sasha? We don't need whiteout. We don't use whiteout. So, what do I need on this triangle, Aisha? That's what I'm being asked to find, yeah? But I need something else as well. I could use the adjacent, yeah? Is there any way of finding the adjacent? No. So the only other thing I could find out is?
Angle.
Well, I need to work out this side, and using trigonometry, I need another side, yeah?
Yeah.
So Maisha said I could work out the adjacent side. But I'm looking at that going, I can't really see how I would work that out. However, I could think, well, what about this side here? Maybe I call that y. That's the opposite side, isn't it? And why might I think about working that one out instead of the other one? What's the clue that I could probably work that one out?
To find the opposite to the bigger triangle, or triangle to the right.
Yeah.
So so you can find an equation using the triangle.
Exactly. So I think we'll go straight for that. Y is also part of another triangle on the left that we do have information for. So the Y, that's why I've picked that one. Okay, go on.
But so you realize that you can't find Y or you find the angle.
Okay, so the problem with this left-hand side is there's no angle. So if there's no angle, what can't we use?
A.
The topic is called? Trigonometry. If there's no angle, because all the work that we've done is the ratio depends on the angle. And we don't have an angle. But I did mention this the other lesson. What do we use when we've got a right-angled triangle and we want to know sides? If it's not trigonometry, we're going to use... Remember we talked about Pythagoras' theorem? So Pythagoras' theorem, remember we talked about it, is if you've got a triangle, a right-angled triangle, and I label the sides A and B, the two sides that make the right angle, and C, the hypotenuse. Pythagoras' theorem states, Nick?
I wasn't here when you did that.
You were.
I don't think I was.
We did it briefly. A squared plus B squared equals C squared. Well, my point, Nick, was that even if you were there or weren't there, you weren't with me at that point. You weren't paying much attention. So you would say you weren't there again. So stay focused at this point. So Pythagoras' theorem states that if I take the other two sides, square them, add them together, I get the other side. Okay. So quite often with these harder trigonometry questions, part of it can be solved using Pythagoras' theorem. You with me, James? Yeah. So, how can we apply that to that triangle we've got?
Add 16, times 16.
So, A squared would be,
16. No, 12 squared.
so 12 squared plus, no, y squared, yeah,
Oh.
is 16 squared. How? Yeah, good question. How? Well, Pythagoras' theorem states that the squares of the two shorter sides add up to make the square on the hypotenuse. Okay, C is the hypotenuse. So,
Y is 4.
so the hypotenuse here is 16. Now, Thomas, the fact that you're giggling and laughing means you're not really focusing on what I'm doing. So I know that the shorter sides are 12 and y, so if I square them and add them together, I should get the hypotenuse, which is 16 squared. Alright? So, what people tend to think is the unknown has to always be what we equal to, but not yet, we have to rearrange it. So any ideas? So, first of all, what's 12 squared? 144. What's 16 squared? That's on the wall.
169.
Nope.
196.
No.
250.
256, yeah.
Oh, that's
So I've got that now. 144 plus y squared is 256. What can I do at this point?
Y is 256 by 1.
Okay, so y squared equals 256 minus the 144. So what's that? Y squared equals
112.
112. Okay. So then y is the square root of 112, which is, you need your calculators. It can't be a negative, you're right. It's not 11. Pardon? 10.58, so should we say 10.6? Makes sense? Okay? Now I'm going to put that up on my diagram. So y is 10.6. Now I have...
Sorry, just, it was the answer and we scattered another way.
So now I have the opposite side for that green triangle. Do you see that?
Yes.
Yeah. So, how do I now solve for x on the green triangle?
You do the angle of a socket.
So we do our SOHCAHTOA. So when we have a test on trigonometry, by the way, I'm going to be looking to see how you lay out your solutions. So I'm going to be looking for you identifying correctly, however you want to do it. But we do SOHCAHTOA, Theta opposite adjacent hypotenuse.
Why is it theta and not angle? I'm using sine.
So theta is just the letter that I give it. This symbol is called theta, just like a Y is a Y and it's a Greek letter. That's what it's called. So what is theta? 40. What's the opposite side?
X.
No. 10.6. What's the adjacent side? No.
Unknown.
Unknown, and do I want to know
No.
it? No. The hypotenuse is x. So which one am I going to use?
Sine.
Nothing with a, so sine. So I have sine 40
Why'd you just
equals,
cross out one with the H?
because it's got an a in it. I can't use anything with an a. So I've got 10.6, because that's the opposite side, divided by the hypotenuse, which is x. Now this is where a lot of my M5s were struggling. When the x is on the bottom of the fraction,
Times it.
do we do
Times by
multiply by x? So I get x times, yeah,
I just remember you said that you could just switch the.
yeah, come back to that in a sec. But let the people remember that. So we've done that, now the next stage is to,
Plug it in your
nope,
calculator.
I've got x times sine 40. I want x.
So, wouldn't it be 10.5 over sine?
10.6 over sine 40, yeah.
10.6 over sine.
So as someone was about to mention, it looks like you can just,
You can switch the X for the.
yeah, it looks like there's switched, but we went through the process. Now we do just plug it into your calculator, and what do we get?
Okay.
Or
16.49.
yeah? Okay, let's just check. It says give your answer correct to 3 significant figures. So that should be 16.5. Now what I would always recommend is go back up to your diagram, stick it in, even if it's the final answer, and just check, does it make sense?
Yes.
Okay, this side has to be the longest. Okay, it's definitely longer than that one, so that's passed. It's definitely longer than that one. It's longer than the 16. Okay, so it looks, but it's not stupidly long. Okay, it's not stupidly long, so it looks all right. It looks fine. Okay. So quite a long question, but did that make sense? Step by step. Okay. Let's have a look then at the next one. Right. Now, do you spot that this question is pretty much the same type of thing, isn't it? So we've got our 2 triangles again. So one triangle is here, and the other triangle is this big one here. Now, what do you notice, right? Which length are we being asked to find?
A to C.
A to C. So if I think about it, A to C is made up of A to D, so I'm going to call that X, and D to C, which I'm going to call
Y.
Y. Sometimes they call it X1 and X2, but what do I have to do at the end? I have to add them together. What do you notice about the orange triangle?
It's
And it's got
No.
a theta, it's got an angle, so I can use use trigonometry. What do you notice about the green triangle? No angle, so I'm going to have to use... Okay. Which triangle do you think you're going to have to do first?
The green one.
No, trigonometry one.
The one with the angle.
Okay. So let me just, yeah, alright, I'll tell you what, I'm not going to tell you much more. You are going to have to work on the orange one first, because you only have one length in the green one. I'm going to let you carry on with that one, see whether you can figure it out. So, with this problem, what you've got to do is take it step by step and think, what do I need to know? How do I find that out? And do I have the information that I need yet, Nick? Okay? I can. Is that right? I don't know. I keep saying it, didn't you keep telling me it's like Adriana in another group. It's Adriana, I don't know. Sorry. I apologise now. Right, so, this question. First off, we decided that we have two triangles. We know we've got to find this length, but we have to do it in two parts. We've already found that out. Now, really, first step would be to find x, because I should be saying to myself, well actually, if I ignore the green triangle, I can say x, well that's going to be, we do our SOHCAHTOA, okay? Theta, opposite, adjacent, hypotenuse. Theta is 65. The opposite side is, well, at the moment we don't know and don't care. The adjacent side is x, and the hypotenuse is
7.
7. So, stop talking. Even if you're getting it right, please don't talk over me. I'm waiting. So the opposite side is crossed out, so let's cross out sine, let's cross out tan. We're going to use cos 65 equals x over 7. Okay? So I've got 7 times, sorry, cos 65 is x. Anyone work that out? No.
That's it now. It's 2.9.
2.9.
Oh, Sophia!
Right. So what I'm going to do is I'm going to write this down as 2.9. Right. Now, I've done the first step that I know how to do. So now I'm going to approach y. So I've got my x, now I'm going to work out y. But I look at the green triangle, and I look at it and say, well, there are no angles. I don't know any angles. Okay? Now, guys, because... stop commenting, please. Just make it so long and tedious. Because there are no angles in the green shape, I know I can't use trigonometry. Now, one mistake, just by the way, that some people do, is they look at the whole bigger triangle and assume that angle is a right angle. How do I know on the diagram not to assume it's a right angle?
Because it's called.
How do I know not to do that? It looks like a right angle, but on the diagram, look, it says...
Diagram not accurately.
So never look at a diagram and say that looks like a right angle when that's labelled like that. Wait for it to actually tell you. Now, you're right, if this green triangle has no angles, we're going to use Pythagoras' theorem. So, I'm going to draw my triangle. I'm going to put y. I'm going to put 12. Now, what's missing? So I need to know this side here before I can do Pythagoras' theorem. So that means, guys, how can I find the question mark so that I can then solve the green one? I have to go back to the orange triangle, don't I? And I have to do a second thing on the orange triangle. Now, I now have an option, don't I? Because on the orange one, I have an angle, but I also have two sides. Therefore, I can use trigonometry or Pythagoras' theorem. Up to you. This is where we have more than one option. Now, has anyone worked that out?
No.
Wait,
Some people have. You can use trigonometry or Pythagoras for the orange. I'm not going to go through it. I'm going to let you carry on from that point. The idea is that I find that, I can then use it for the next triangle. Okay? Off you go. Yeah.
So I'm going.
Okay? So, what we do is we've worked out that we need to know this length here. We're going to use this triangle to work that length. So there's lots of ways to do it, but what I'm going to do is say, I'm going to use trigonometry again. Theta, opposite, adjacent, hypotenuse. This time 65. The opposite is one I want to know. The adjacent not. The hypotenuse is 7. So I'm going to use sine 65 is question mark over 7. I work that out and I get question mark is 6.34, I think.
Yeah.
So that's this side. I then take that down to here, 6.34. Now I've got the information to find y. So I write out Pythagoras' theorem would be 12 squared equals y squared plus 6.34 squared. So I rearrange, minus 6.34, and I take the square root of that, gives me y. And I think I end up with something like 10.2. So that's 10.2 up there. And then the answer is obviously those added together. So the answer, final answer, A, C is 13.1. Yeah, a lot of people forget that. That's,
what?